Here we're going to talk about how to classify triangles and then show you some examples of some potential questions you might get on the GED test regarding triangles and the classification of triangles. So the first way that we're going to classify a triangle is based on the measurement of their angles. So this is related to the video on geometry terms, so if you haven't watched that, please watch that first. But the first way that we're going to classify a triangle is based on the measurement of its angles. If all of the angles inside the triangle are less than 90 degrees, this is called an acute triangle. It just means that all of these angles are less than 90 degrees. If you have one angle that is greater than 90 degrees, so for example, this angle here is greater than 90 degrees, this is called an obtuse triangle. And the last one is if we have one angle that is exactly 90 degrees. So if this angle here is exactly 90 degrees, it's usually denoted where we put this little box here. That means that it's 90 degrees. These are two perfectly perpendicular lines forming a 90-degree angle. This is called a right triangle. And so this is important to remember, especially the right triangle. You need to know that when you see the term right triangle, it means that it has one 90-degree angle in it, because you're going to get questions. There are certain properties about right triangles that we'll do in future videos, but there are questions that you'll get that are particular to right triangles. So it's good to know these terms, acute, obtuse, and right, and what they mean. That the angles in acute are less than 90, obtuse has one that's greater than 90, and right has an angle that is exactly equal to 90. So that's the first way to classify triangles. The second way is based on the length of their sides. So if we have a triangle in which all the sides have a different length, so the length of that side is different than the length of that side, which is different than the length of that side. All of them are different. This is called a scalene triangle. All the lengths of the sides are different. If you have a triangle in which two of the sides are the same length, so the length of that is the same as the length of that, this is called an isosceles triangle. The way that we denote the two sides that are equal is with those two hash marks. So that means if the length of this side is 5, then the length of that side is also 5. And it's good to know this term because you will have some questions, and you might get a word question that just says, hey, we have an isosceles triangle, and you'll need to know that the length of the two sides are the same. The final one is with an equilateral triangle. And with an equilateral triangle, all of the sides have the same length. So the length of that is the same as the length of that is the same as the length of that. So here's definitely a term that you need to know, because you might again just get a word problem that says you have an equilateral triangle with side of length 8. So you'll need to know, they'll go on and ask you something further, maybe about perimeter or something. So you'll need to know that, okay, it's an equilateral. If one side has length 8, then all the sides have length 8. So equal, all sides are equal. So these are important to know, especially isosceles and equilateral. The other thing that you must know about triangles is that when you add up all of the angles inside of a triangle, regardless of what kind of triangle it is, they always have to sum to 180. So when you add up all of the angles, they have to add up to 180 degrees. This is very important. It's for every triangle. It doesn't matter what type or size of triangle it is. The angles inside the triangle have to add up to 180. So here's an important thing about equilateral triangles. Not only are the sides the same length, but all of these angles inside also have the same measurement. So the angles are all the same inside of an equilateral triangle. So if they all have to add to 180 degrees, what is the length of any one of these angles? Well, it has to be 60 degrees. Each one has to be 60 because they have to all be the same. That's by definition in an equilateral triangle. They're all going to be the same measurement, and they all have to add to 180. So 180 divided by 3 is 60. So 60 plus 60 plus 60 equals 180, and they're all the same. So that's good to remember. You can figure it out if you're ever asked on the test, but what is the measurement inside of every equilateral triangle? It's 60 degrees. The other important thing to remember is with isosceles triangles. Not only are these two sides of equal length, but these two angles down here are also the same. So I'm going to denote them by a variable x. So the measurement of this angle is the same as the measurement of that angle. Not necessarily this one. That one doesn't have to be the same, and in fact will not be the same unless it's an equilateral triangle. So, but these two angles are going to be equal. So if we do an example, so they may just show you a picture. They'll draw an isosceles triangle, they'll have these two hash marks, and they'll say, I'm going to draw it outside. They'll say the measure of that angle is 40 degrees. What is the measure of angle X? That might be a question. So this is going to take a little bit of algebra. If you don't know how to do algebra, please watch the algebra video, as I'm going to do it fairly quickly here. But this is really not that bad of a problem. If they draw you this, that measurement is 40 degrees. What's the measurement of this? Well, we know with isosceles triangles, so this is why it's important to remember, we know that that angle and that angle are the same. So if this equals x, then this equals x. And all these three have to sum to 180 degrees. So we're just going to add them together. 40 plus x equals 180. And we have an algebra problem, which I'm going to do quickly, so please watch the algebra video if you don't know how to do this. We have 40 plus 2x equals 180. We're going to subtract 40 from each side, so we have 2x equals 140. To get x by itself, we're going to divide by 2, so we have x equals 70. So the measurement of this angle is 70 degrees. The measurement of this angle is also 70 degrees. 40 plus 70 plus 70 equals 180. So we know that that is correct. Okay, the last type of problem that I'm going to show you has to do with vertical angles and triangles. There was a video on vertical angles on the Facebook page, so if you haven't watched that, please watch that before we do this. So if they give you a drawing that looks something like this, and these are all lines. So these are all crossing lines. And they tell you this is 40 degrees, and this angle is 60 degrees. And they want to know what is the measurement of that angle, n. We're going to denote that by the variable n. So here you need to know two things. You need to know about vertical angles, and you need to know about triangles. So if you remember, in vertical angles, when you have two crossing lines, the angles opposite each other are the same. So if this is 40 degrees, we know this is 40 degrees. We also know if this is 60 degrees, that this is 60 degrees. So now we can figure out what this is, because this is a triangle here, right? And we know that the angles in a triangle have to sum to 180. So we have 40 plus 60 plus, we're going to just denote this as x, plus what equals 180. 40 plus 60 plus what equals 180. 40 plus 60 is 100. We're going to subtract 100 to get x by itself, so x equals 80. So now we know that this angle is 80 degrees. So now we need to know actually one more concept about supplementary angles. So again, watch the video on geometry terms, but we know that the angles along a line have to sum to 180 degrees. That was on the geometry term video with supplementary angles. So we know if this is 80, 80 plus n has to equal 180. So n equals 100. So just by giving us these two angles, we are able to figure out what this angle was. But we used three concepts here. Vertical angles, the fact that the sum of the angles in a triangle equal 180, and the fact that the angles along a line also have to sum to 180. And we got that answer.